Welcome to the session on forces and motion, forces and acceleration. The objectives for this session are to understand and use Newton's second law of motion, F equals ma, or force equals mass times acceleration. Recall that if two forces, Ai plus Bj newtons and Ci plus Dj newtons, are acting on a particle, the resultant force is the sum of the forces. When a non-zero resultant force acts on a particle, the particle will accelerate in the direction of the resultant force. Let's now take a look at Newton's second law of motion. The force required to accelerate a particle is equal to the product of the mass m of the particle and the acceleration a produced. So F equals ma. Let's take a look at some examples. A force of 1 Newton acting on a mass of 1 kilogram accelerates the mass by 1 meter per second squared. If a force of F newtons acting on a mass of m kilograms accelerates the mass by a meters per second squared, then F equals ma. This is also known as the equation of motion. Let's take a look at another example. The force acting between any object and the Earth is gravity. The weight of the object is the force due to gravity acting on an object. The weight acts vertically downwards. So if a body falls freely with acceleration g equals 9.8 meters per second squared on a mass of m kilograms and weight w, then the equation of motion for the body is W equals mg. Now let's take a look at another example. Suppose a particle has mass 3.5 kg and is acted on by a resultant force of 8n. Calculate its acceleration. The equation of motion for the body is F equals ma. Therefore, 8 equals 3.5 times a. And rearranging this equation gives us that a equals 8 over 3.5, which is 2.3 meters per second squared. Now let's take a look at another example. In the diagram below, the body is accelerating as shown. Find the magnitude of the forces x and y. Let's first resolve the forces horizontally. So resolving horizontally gives us 30 minus x, which is the force, equals 2, which is the mass, times 7, which is the acceleration. Rearranging gives us that x equals 16n. And resolving vertically gives us 15 minus y, which is the force, equals 2, which is the mass, times the acceleration, which is 0. And therefore, we have that y equals 15n. And now for the next example. In the diagram on your screen, The body is accelerating as shown. Find the magnitude of the forces x and y. So let's begin by resolving horizontally first. We're going to resolve in the direction of acceleration, which is towards the left. So we have the force, which is 25 minus x, equals the mass, which is 7, times 3, the acceleration. And tidying up gives us x equals 4n. Now let's resolve vertically. We have y minus 8, because notice y is acting upwards, 8 is acting downwards. And of course 7g is acting downwards as well. So overall we have y minus 8 minus 7g equals mass, which is 7, times acceleration, which is 0 in this example. And tidying up gives us y equals 8 plus 7gn. And of course we're taking g to be 9.8, so plugging that in and calculating gives us that y equals 76.6n. Now let's take a look at the next example. A block of mass 4 kilograms is pulled from rest along a rough horizontal surface by a horizontal force of size 15n against a constant frictional force of magnitude 3n. Find its acceleration and the distance it travels in the first 5 seconds. So let's begin by producing a force diagram. So here's our mass of 4 kilograms, or block of mass of 4 kilograms. We have a horizontal force of size 15n. We have the weight, which is 4gn, because of course the mass is 4 kilograms, therefore the weight is going to be 4g, or 4 times the force of gravity. And we have the frictional force, which is opposing the direction of motion, which is of size 3n, as shown. And of course, the normal reaction force as well. We've also indicated acceleration, which you can see moving in the direction in which this mass is being pulled. We're required to find its acceleration. So let's resolve horizontally in the direction of acceleration. So we have 15 minus 3, which is the force, equals 4, which is the mass, times a, which is the acceleration. And this gives us that a equals 3 meters per second squared. We're next required to find the distance the mass travels in the first 5 seconds. So let's substitute the values in this formula, s equals ut plus a half at squared. We're required to find distance. We have the initial velocity, because the block of mass is pulled from rest, so therefore u equals 0. We have the time, which is 5 seconds. And we now have the acceleration, which is 3. And so we have, once we've tidied up, that s equals 37.5 meters. This brings us to the end of this session. If you have understood its contents, you should be able to understand and use Newton's second law of motion, force equals mass times acceleration, or F equals ma. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.